Thank you very much. Welcome, everybody. My name is Leonardo Trabuco. I lead the data platform area at Nubank. We have some teams based in Brazil and some teams based in Germany, and I'm calling from Germany today. And the title of my talk today is Successes and Challenges Related to Data Democratization at Nubank. So what I thought I would do is, instead of trying to cover all the ground, I'll walk you through a couple of examples to illustrate some of the successes and challenges that we have been experiencing. So let's follow the journey of a data scientist that is trying to use our platform to build a machine learning model. Let's say I'm a data scientist and I want to explore all the customer purchases as a potential feature for my model. So what do I do? In our architecture, we typically will have microservices that you can see here in orange in the production environment that will own a certain entity, and you have multiple copies of a microservice running in a production cluster, in this case, Kubernetes, and they're all writing to a database. And in our case, we use Datomic as a technology. And you can see here that you have services in shard 1, shard 2, etc. And you can think of these as multiple copies of the core infrastructure, Kubernetes clusters, Kafka clusters, load balancers, what have you. And it's a way for us to scale as we grow the number of customers. So you may have a customer sort of living in shard 1, and nearly every flow through the microservices that involve that customer will live in shard 1, whereas for another customer, it might live in shard 2, etc. So what this means here is that if there is one service that is responsible for writing all the data related to purchases, you're going to have a bunch of that data in each of these databases, in each of these charts. So what the platform provides in our case is that we have an automated way to discover all of these Datomic databases in all the different shards for every microservice that uses them for every country, and automatically ingest those transactional logs and transform them and materialize their views in a way that it is much easier to consume for analytical users. So in a tabular view with all that complexity about the shards and the databases, the internal database structure abstracted away. So as a data scientist, that's the first success there. I can start here. I don't need to worry about any of that complexity that I described in the production environment, and I can immediately start exploring data in an easy way with familiar tools. I can use SQL, I can use a notebook, I can use a BI tool, etc. Now I want to build some features, right? So what you can do in our data platform is to consume from that materialized view, or multiple of them, build a transformation using Spark, for example, and create a derived data set that has all the features that you need. And from there, you can maybe score a model that goes to production. I'm not going to cover here how we train models and put them into production. I can cover a bit of that in questions if there are. Now, one first complication. So let's say that a customer comes along and says, hey, please delete all my data, which is something that can happen. And by according to data protection laws, we have to process these requests, understand and map where all the data for a given customer is, understand which data we are supposed to delete, which data we're supposed to keep for a certain time for regulatory reasons. And in this case, well, data for this customer may be in any of these charts. I need to know where this customer lives, and then know all the databases that are relevant and so on. So as a data consumer, as a data scientist that perhaps is using some of that data, oh no, what do I do? I have to deal with that. That's another case where the you get leverage from a platform like this, because the platform handles all the complexity for you, right? So the platform will handle any request from data subjects like this. We'll figure out where the data lives according to a data inventory. We'll excise the data from any relevant database. We'll take care of invalidating any caches and re-extracting the database transaction log segments that are relevant, rebuilding that materialized view, and we follow functional programming thinking in the structuring of our analytical environment, which means that naturally every step that you see here is immutable and is going to be reconstructed in the next time that we process data. So any data deletion that we do at the beginning of this process will naturally propagate through, in this example, the feature computation and the model scoring last data set. You see that. So as a data scientist here, as a user, that is all transparent, and you don't need to worry about any of that. So those were a couple of examples of some successes that you get from this investment in a platform like this. So let's talk a little bit about a few others, and especially challenges that come along as you scale the use of a platform like that. So let's imagine that you're consuming from, so I simplified a little bit the diagram here, and you have, imagine that entity A here is the same as you saw before. It is a view coming from a given production database. And in the past, entity A had all the purchases that I cared about in our example. But now the product evolves, and now you have new microservices with new databases generating data about purchases that are unrelated to the first one. Now you have purchases split across multiple entities, and your input is incomplete, right? You have incomplete sensors here. So what do? In a situation like this, one of the things that we're investing on is in the creation and evolution of canonical data sets that maintain a more durable interface for all the analytical users and abstracts away the complexities of refactors in services and new services being added, so that you only need to change them that purchases data set, and any consumer that depends on it will get that for free. That's how the happy path looks like. Our data scientist is consuming from a canonical, high quality data set that is well monitored, well tested, and there's clear ownership to evolve it over time. Now let's say another data scientist comes along and thinks, well, I can add a feature to the same features data set for my new model P, but I can reuse all the other features that are already computed there. And that saves me a lot of work. And we only need to compute those features once. So that's great. I can get, that's one piece of data democratization. I can get that reuse and start working always at a higher level of abstraction. It turns out that this feature that I'm adding to this features data set is a little bit expensive to compute, but I think it's totally worth it for this model that I'm building. And I have a huge ROI, so that's not a concern. But it turns out that by adding this new feature to this common data set, the runtime for computing that data set, features data set, just went from 2 hours to 6 hours. Now another consumer that had nothing to do with it has the consequence that their model is being delivered 4 hours later than expected. So now imagine that you have dozens of data science that are actively evolving features, adding features to this common data set. And you have hundreds of other users making changes to data sets in this graph of computation that I just showed in any given week. And that for the nodes of that graph, you have over 80,000 of them, and that's growing quickly. And that you have not just one or two users downstreams, but you have many different critical use cases all over the company that are relying on those data sets. So just to paint a little bit of a picture of how the complexity and challenges evolve over time with the scale, right? And both in terms of data and number of users. And here are some of the ways that we're trying to tackle these challenges. So first of all, we invest on a lot of platform level performance optimizations. So anything that we can do at a platform level that is transparent to users is a win. We are investing in teasing apart the different levels of criticality for data sets. So how do you discern between all those 80,000 data sets and different paths through the graph, which ones are more important than others, which ones are more time critical than others, and solidifying the distributed ownership for their maintenance, increasing visibility on the health of data sets and their costs, evolving the constraints that we add to the contribution of these data sets and how we recover automatically from failure. So we already have certain strategic constraints that we impose in this platform. Just to give you one example, we enforce that all of those transformations that you saw are pure functions. That means that there are no side effects in any of them. They're just declarative transformations without any side effects, which means that as platform owners, what we can do is safely retry any failure or do speculative execution of any of these data sets for performance reasons in a safe way, because we know that rerunning a given data set is safe because they're all pure functions. But there are other constraints, many other constraints that we have and we can add and evolve to ensure scalability. And then finally, investment in smarter scheduling of this large computational graph to improve utilization, to improve, reduce blast radius, and inform refactors of data pipelines. All right, I think that's it for me. Happy to take any questions.
Thank you, Leonardo, for the talk. Also, thank you for all the work in the data platform. It's very useful for us. All right, let's see if we have questions here. All right, so the first question is, any thoughts on data mesh approach?
Right, so we're evolving towards something at Nubank, towards something that looks a lot like what people are calling today data mesh. I think one big difference from some interpretations of data mesh is that we have today a unified graph of computation that makes any of these data sets available for reuse and to make derived pipelines. There's a single transaction where everything gets computed in a consistent way. The way that some folks talk about data meshes, those things tend to be a little bit more isolated, and they expose clear interfaces, data products that you can consume from each other. But if you think about these canonical data sets and or critical tier one data sets that you have clear interfaces and guarantees, you can squint and reason about them as the what you're exposing in your data mesh, the products that you're exposing in your data mesh that can be consumed by other teams. So in my view, we're kind of doing it and moving towards more of that, but without giving away the advantages of having the power of having everything available in the same data lake, in the same graph of computation.
So the second question we have is, what tech stack do we use for MLOps?
Sure, I can give you a very high level overview of the tech stack that we use for training, deploying, monitoring machine learning models. Maybe other folks in the call can complement, but let me focus on like the example that I gave before in the batch world, right? We have for feature engineering, the stack that we use is similar to the other consumers of data at Nubank. We have all the data available in a data lake. Folks use tools like Databricks or other notebooks to explore the data and build new data sets or change data sets. The main way to build data set transformations in our stack today is through Spark, defining in high level project that we have building on top of Spark. You define your transformations and we manage and run them for you. The next step to train the models, we have I think some open source tools in Python to train models. We use as an infrastructure today Kubeflow to orchestrate all the training pipelines. And to deploy, if you stick with the production, with the batch world that I was showing, you can deploy a batch scoring job in either in Python or we have some tools to do automatic translation to Scala so that we can take advantage of a lot of other guarantees that the platform provides. And one of those boxes that you see there would be that run. And then finally, the output of that model might go through what we call the serving layer and be made available to production services to react to the actuators that Jacob was talking about. And then we have some extra jobs to do model monitoring and provide some visualizations in a BI tool, some automated alerting and things like that. So hopefully I gave some idea.
Yeah, I think that's really that seems helpful. We have many more questions showing up. So the first one here is when a new feature is implemented, do model A results not change or is model recompiled?
Right.
Okay.
So I guess I understand. So if you're changing a feature that is being consumed by model A, then yes, potentially that would change, and that's where all the governance around change management for data sets and also monitoring at different levels will be important. But if you're adding another feature that is not being consumed, then no, right?
So now you mentioned 80K data sets. How many rows and columns do they have on average?
Good question, and I really don't know.
A whole lot.
It varies a lot, right? So there are data sets that are pretty narrow, but others will have millions or billions of rows, depending on the case. If you're looking at history data sets for all customers, right? Yeah.
So what is the frequency of this batch run?
For us today, that's daily. We have a few other workloads that key off of that may run at different frequencies, but that the main transaction that we run that I showed you is today daily.
All right, last question here is, do data scientists build their data sets querying directly the data lake, or do we have any feature store solution deployed?
So a bit of both. So in the example that I showed, well, to build their data, so they can build their data sets and new features in the way that I showed. You can see that features data set kind of as a feature store, a primitive one. We do have a feature store in production that we are evolving, and that is combining the batch and the online world. And you can, if there is, for example, a feature that is computed in a streaming way that is registered in that feature store, or a batch one for that matter, and that already works for you, and you're developing a new model, you can just consume from it, right? And if you're developing a feature, you can contribute to that feature store, and others can reuse that.
Awesome. Thank you, Leonardo. That's all the questions we had. And thank you for the talk.
Very welcome.